The universe is a vast and mysterious place and home to some of the truly horrifying and dangerous planets. Planets filled with extreme conditions that would make them impossible to live on for any known form of life on Earth. But just because these planets aren't habitable now, doesn't mean we aren't capable of transforming them into places that we could live in. Let's start with the universal solvent, water. It is the main component of all living cells and is essential for survival, taking up 60% of our body mass, regulating our body temperature and helping our brain function. But we're not the only ones who rely heavily on water. Take the jellyfish, for example. These creatures are made up of 95% water, so I think it's safe to say we're lucky to have an abundance of this precious resource. But on GJ436b, let's just say things are a bit different. You see, GJ436b has water, but not as we know it. It's not the refreshing, life-giving liquid that we're familiar with. Instead, it's hot ice. Now, by hot ice you might think of dry ice where it is just gas. But when I say hot ice, I actually mean ice that burns your hand. It's like eating a chili cucumber and then tasting a Carolina Reaper. This creates a strange state of matter called supercritical water, which is a liquid that has the properties of both a gas and a liquid. But that's not even the craziest thing about the planet. As the hot ice constantly evaporates, it gets blown off of the planet by the radiation from its star, creating a comet-like tail that is about 14 million miles long, or about 4,000 times longer than the distance from New York City to London. But how can we live on a planet with burning ice? Well, terraforming isn't just about making a planet look like Earth. It's about making it livable for us. And while a planet with burning ice might not seem like the most hospitable place, with the right technology, we could potentially turn this extreme environment into a new home for humanity. One potential solution could be to develop technology that can convert this hot ice back into a liquid state. Think of it like this. You know how when you put water in a freezer, it turns into ice? Well, on GJ436b, the hot ice forms under very high pressure and heat. So to turn it back into liquid water, we need to create a machine that can recreate those conditions. It's like having a special freezer that can make ice into water instead of the other way around. Now, creating such a machine would be a big challenge. We need to understand exactly how the hot ice forms and then design a system that can apply the same amount of heat and pressure. This could involve using powerful heaters and pressure vessels controlled by advanced computer systems to ensure everything is just right. Once we have that machine, we could take the hot ice, put it in the machine, and turn it back into liquid water. This water could then be used for all sorts of things. We could drink it, use it to grow plants for food, or even use it to create oxygen for us to breathe. It's like having a magic box that can turn a deadly environment into a life-supporting one. Harnessing the energy from the evaporating hot ice could also be a key part of living on GJ436b. We could potentially develop technology that captures this energy, similar to how solar panels capture energy from the sun. This could provide a renewable source of power for the colony. If you are wondering if this is even possible, I tend to lean on the more optimistic side and say if we focus all our energy on trying to live on this planet, it is definitely achievable. But another planet has perhaps even more peculiar weather. This planet, known as HG 189773b, is located 63 light-years away from us, and it's a place where the weather forecast is terrifyingly always the same, hot with a chance of glass rain. But the scariest part about it is that it isn't falling like the rain you would see here on Earth. It's whipped around by winds reaching speeds of over 5,400 miles per hour. If you're wondering how fast that is, it's 7 times faster than the speed of sound. To put that into perspective, if you were to travel at that speed, you could travel from the North Pole to the South Pole in just under 3 hours. Now, if you are one of those lucky ones where the glass doesn't get you, and you somehow don't fly away with the wind like Superman, the heat will definitely make an impact. This planet is so close to its star that its temperature can reach a scorching 930 degrees Celsius, which is about 5 times hotter than an oven set to a typical baking temperature. So if you thought a hot summer day on Earth was unbearable, imagine trying to survive on HD 189773b. You'd be dealing with winds that could carry you from pole to pole in hours, showers of molten glass, and temperatures that could turn you into a human barbecue. Not exactly a vacation destination, is it? But after all, we're talking about terraforming, right? Who knows, maybe we want to make this place our Azkaban. Well, first we need to deal with the extreme temperatures. One way to do this could be to build structures that can withstand the heat. Think of it like building a house out of fireproof materials, but on a much larger scale. These structures would need to be insulated to protect us from the outside temperature, much like a thermos keeps your coffee hot or your iced tea cold, regardless of the weather outside. Next, we need to find a way to breathe. The atmosphere on HG 189773b is mostly hydrogen with traces of helium and methane, things you would find balloon in a nuclear chemical plant, not exactly a human-friendly mix. So we'd need to find a way to generate oxygen. This could be done by bringing plants to the planet, which produce oxygen through photosynthesis. These plants would need to be genetically modified to survive the extreme conditions, but hey, we're already doing this to an extent. And the glass rain and abnormal winds are another issue. We need to build our structures to withstand these conditions, maybe structures built like bunkers, heavily fortified and anchored deep into the ground. The exteriors would need to be resistant to the glass rain, perhaps made from advanced ceramics or metals that can withstand the high-speed impacts. Lastly, we need to find a way to generate power. The intense radiation from the planet's star could be harnessed using solar panels, providing us with a renewable source of energy. Now, all of this might sound like science fiction, but remember, so was going to the moon just a few decades ago. With the right technology and a lot of determination, it is theoretically possible to live here. But possibly the deadliest planet in the universe is the most unlikely to terraform. Welcome to Kelt 9b, the hottest planet in the universe. This planet is so hot that its daytime temperature can reach over 4,300 degrees Celsius, which is hotter than some stars. It's so hot that molecules such as water, carbon dioxide, and methane can't even form. In terms of resources, the planet's atmosphere could potentially be mined for helium-3, a rare isotope on Earth that could be used as fuel in future nuclear fusion reactors. But if you're thinking of packing your bags and moving there, you might want to reconsider. It would require us to develop materials and technologies capable of withstanding the heat. And currently, the highest melting point of any known material is tantalum hafnium carbide, with a melting point of 2477 degrees Celsius, which is still far below the temperatures on Kelt 9b. But if all else fails, we can still grab some bedrock from Minecraft and build a tiny vacation house if we absolutely need to. However, even if we did have a material that could withstand the heat, there would still be many other challenges to overcome in order to make a planet like Kelt 9b habitable, including its lack of a solid surface, its extreme radiation, and its inhospitable atmosphere. That being said, human ingenuity knows no bounds. We've climbed the highest mountains, dived to the deepest parts of the ocean, and even walked on the moon. So who's to say that we won't live on this fiery planet?